This video is part 2 of a solving exponential and logarithmic equations. So in our first part, we went over the 3 strategies for solving exponential and logarithmic equations, so I just want to revisit those really quickly. So a first strategy would be to rewrite the original equation in a form that allows the use of the one-to-one properties of exponential or logarithmic functions. Our second strategy would be to rewrite an exponential equation into logarithmic form and apply the inverse property of logarithmic functions to it. And the third strategy would be to rewrite a logarithmic equation in exponential form and apply the inverse property of the exponential functions. So let's go ahead and let's go down to where we left off with our final examples. So here we have the natural log of 3x equals 2. So in this particular instance, we're solving a logarithmic equation. So we want to write it in exponential form. So we're going to want to know what is the base of that natural log. And its base is e. So what that means we want to do is we're going to take and make e the base of both sides. And that allows us to cancel out the e and the natural log. And that drops down our 3x. And we set that equal to e squared. From there, we'll divide both sides by 3, and we can either leave it as an x equals e squared over 3, or we can even rewrite this as an x equals a 1/3 times e squared. Either way, it means the same thing. When we plug that into our calculator, that's going to give us the value that x is going to be approximately 2.46. So here we're looking at our exact solutions and our approximated solution as well. For letter G, we have 5 plus 2 times the natural log of x equals 4. So we'll begin by solving this by getting that natural log by itself. So we'll subtract 5 from both sides, leaving us 2 times the natural log of x equals a -1. From here, we will want to divide both sides by 2 to get rid of that 2. And now we've isolated our natural log of x. So we have the natural log of x equals a -1/2. So again, here we have a logarithmic equation. So we want to rewrite it in exponential form. So we want to know what is the base of a natural log. And the base of a natural log is e. So if we take e and make that the base of both sides, that is allowing us to use the inverse property to cancel out the e and the natural log on the left-hand side, which then leaves us with x equals e to the -1/2 power. And so that's going to be our exact solution. And when we plug that into a calculator, we get our approximate solution, which is 0.61. So here we have our exact and our approximated solution. Let's take a look at another example. So here we have 2 times the log of base 5 of 3x equals 4. So we want to get that log base 5 isolated. So to do that, we're going to begin by dividing both sides by 2. So that will eliminate our 2. And then we have the log base 5 of 3x equals 2. So here we have a logarithmic function, and we want to rewrite it as an exponential to get rid of that log. So we want to look at the base of our log. So by looking at the base of our log, we see that we have a base of 5. So that means we want to take 5 and make that the base of both sides, because that is what allows us to eliminate the 5 and the log base 5, leaving us with 3x equals 5 squared, which we know is 25, right? So we have 3x equals 25, and we're going to divide both sides by 3, which is going to give us x equals 25 over 3. And now we want to make sure that we check this and make sure that it's actually going to work out. So we plug it back into our original. So if I were to do that, then I would have something like this for my check. So I'm going to take my x and I'm going to replace it. So I'm going to have the log base 5 of 3 times 25 over 3. And we want to know, does that equal the 4, right? So I'm going to go ahead and I'm going to multiply, because we know that this whole thing is what is log base 5 is being taken of. We're going to simplify that down. So we have 2 times the log base 5, and 3 times 25 over 3 is just 25. And from here, to be able to check to see if that equals a 4, we need to use our change of base formula. So what we're going to do is that means we're going to have 2 times the log of 25 over the log of 5. And when we plug that into our calculator, that's going to give us a value. Let's give it a little more room. There we go. A value of 4. So then when we look up and we check, we see that it is in fact a match, meaning that we do in fact have a solution of 25 over 3. Let's take a look at letter I. This will be the last example that we do for this. So here we have the natural log of x minus 2 plus the natural log of 2x minus 3 equals 2 times the natural log of x. Now this one might seem really overwhelming, but we're able to use some condensing. Because we have a plus sign there, that tells us these natural logs are actually being multiplied. So we need one natural log, and then we're going to be multiplying that x minus 2 and that 2x minus 3. The plus sign right here, that's what allows us to do that. So we're condensing that piece down, and then we're going to set that equal to 2 times the natural log of x. Now, using our properties of logarithms, we know that when we have a number out in the front, we're able to write it as the exponent. So what we have here is the natural log. And let's go ahead and let's FOIL this right here. Let's FOIL that and let's get an answer. So we're going to take that x minus 2 times 2x minus 3, and we're going to FOIL that and get a 2x squared minus 3x minus 4x plus 6, or a 2x squared minus 7x plus 6. So we'll plug that in. So 2x squared minus 7x plus 6 equals a natural log of x squared. Now from here, it actually gets pretty simple. Because we have the natural log and the natural log, those actually are going to cancel out, leaving us with 2x squared minus 7x plus 6 is equal to x squared. So now we're just going to simply solve. So we will subtract x squared from both sides, which will leave us with an x squared minus 7x plus 6 equals 0. And we're going to try and factor this. So are there two numbers that will multiply to 6, but that will add to 7? And the answer is yes. You could use a negative 6 and a negative 1 to do that. So from here, we can use our zero product property. So let's go ahead and let's move over here and give ourselves a little bit of space to work. So we're going to be able to take that x minus 6 and set it equal to 0, and take x minus 1 and set it equal to 0. And then we're going to solve for x. So we'll add 6 to both sides, get x equals 6, add 1 to both sides, and get x equals a 1. So here we have two solutions. And now we just need to check those. So we're going to check them by putting them back into our original equation. So we're going to go ahead and let's check our 6 first. So let's go ahead and let's give ourselves a little bit more room to write. So here we have the natural log of 6 minus 2 plus the natural log of 2 times 6 minus 3. And that's supposed to equal 2 times the natural log of 6. So that means we're going to be plugging some of this stuff into our calculator. So we'll plug in our natural log of 6 minus 2 plus the natural log of 2 times 6 minus 3. And that's going to give us a 3.583. And then if we take 2 times the natural log of 6, we're going to get also a 3.583. So here we see that our 6 checks out. And so we know, because those are equal, that our 6 is a solution. So now we're going to do the same thing, but this time with the 1. So we're going to have the natural log of 1 minus 2 plus the natural log of 2 times 1 minus 3. We want to see if that equals 2 times the natural log of 1. So we pull up our calculator again, and we will plug that in. So we'll plug in our natural log of 1 minus 2 times plus the natural log of 2 times 1 minus 3. That's going to give us an answer of no real solution. Interesting. Well, what if we plug in 2 times the natural log of 1? That gives us a 0. And so we see that those don't match. So here we had no solution, and here we had a 0. And so we can see that our 1 is an extraneous solution. So only 6 is a solution here. So again, it's really important to make sure that you're checking your solutions.